Hey everyone, and welcome to This Explainer. Today, we're zeroing in on something incredibly powerful, real Python coding. We're diving deep into variables and data types, pulling straight from the curriculum over at PD Coding Hub. So if you're ready to build a completely rock-solid programming foundation, well, you're definitely in the right place.
Okay, let's dive into this because real Python coding starts right now. Literally right this second. We're tossing out the dry theory today and getting our hands dirty with the actual mechanics of how code operates. This is that magic moment where you transition from just reading about programming to actually building with it.
All right, section 1. What is a variable? The absolute foundation of storing data.
So what exactly is a variable anyway? Well, in its absolute simplest, purest form, a variable is just used to store data. I want you to picture it like a neatly labeled storage box. When you're writing a program, you have all this floating information, right? Names, numbers, account statuses. And you need a secure, reliable place to stash it so the computer can easily find it and use it later. That digital storage box, that's your variable. Let's see how this actually works in a live coding environment. Check out name equals Pawan. What we're doing here is taking the text Pawan, which is our data, and securely dropping it into a variable box that we've labeled name. Honestly, it's truly that simple. You just assign the value on the right side of the equal sign to the label on the left. Boom, done. Now let's build on that a little bit. We've kept name equals Pawan, but check it out. We've added a totally new box, age equals 25. So now we've successfully stored two entirely different pieces of information. But how do we actually see what's inside these boxes? Well, that's exactly where the print command comes in. By typing print name and print age, we are literally commanding the computer to crack open those boxes and reveal the data inside right onto the screen. It's your most basic but absolutely most essential tool for talking to your code. Which brings us perfectly to section 2, the 4 data types. This is all about categorizing our stored data. And this brilliantly illustrates the core materials we actually have to work with in Python, the 4 foundational data types. You've got your string for text, your integer for whole numbers, your float for decimals, and your Boolean, which is basically just a simple logic switch of true or false. Seeing them all laid out side by side like this really helps you spot the structural and visual differences right away. Let's isolate those first 2 just to really lock this in. First up, the string, which we abbreviate as str in our code. See name equals Pawan? The absolutely crucial detail there is the quotation marks. That is the exact signal that tells Python, hey, treat this explicitly as text. Then we've got the integer, or int. Look at age equals 25. Notice how it's just a whole number, completely clean, no quotes around it at all. The computer treats these 2 formats very, very differently under the hood. Okay, now for the remaining 2. The float, abbreviated simply as float, handles our decimals. So for example, salary equals 25,000.50. Pretty much anytime you're dealing with money, weights, or highly precise measurements, you're absolutely going to use a float. And finally, the Boolean, or bool. Fun little fact here, this is actually named after the 19th century mathematician George Boole. Booleans represent binary logic states, so on or off, yes or no, true or false. Notice that true has a capital T and absolutely no quotes. It's a fundamental logic block for directing traffic inside your programs. Moving smoothly right along to section 3, checking your data types. Time to look under the hood. I want you to think about this for a quick second. If you're building a massive, complex application, you can't just guess what's inside a variable box, right? A wrong guess will literally crash the whole program. You need definitive proof. So, how do we actively ask Python to just tell us the data type? Well, here is your answer, the incredibly useful type command. By wrapping our variable inside the type command and then putting that inside our trusty print statement, we get our definitive proof. Print type of name will output str for string. Print type of age tells us it's an int. We do the exact same thing for salary and isActive. This proves exactly how Python is categorizing our data behind the scenes. Trust me, it is an unbelievably powerful debugging tool to have in your back pocket. So the crucial point is, how do we use this? Let's transition to section 4, real-world data analytics, putting variables to work. Let's walk through a real data analytics scenario together. Imagine you're tracking user behavior for a big e-commerce platform. We set customer name equals Rahul. Boom, that's our string. Then Purchase amount equals 5,000.75. There's our precise float for currency. And is member equals true, our Boolean logic tracking their loyalty status. When we print all these out, we can see exactly how seamlessly these totally different data types come together to build a complete, actionable customer profile. Honestly, this is exactly how massive global databases start organizing their data.
Which brings us to our final leg, Section 5, Common Mistakes and Your First Mission. Let's avoid some errors and get to practicing.
Now, what's really interesting about this is how a single missing character can completely shatter your code. If you try to write name equals Rahul without any quotes, Python looks at that and gets totally confused. It thinks Rahul is supposed to be another variable box, not a text string, and it will immediately throw an error. But then, the correct version, name equals Rahul wrapped tightly in quotes, those quotes are the magic boundary that tells Python exactly what to do. So, golden rule, never forget your quotes when you're writing strings.
And the second most common pitfall? Wrong variable naming. If you just use arbitrary letters or random symbols, it makes your code virtually impossible to read. On the flip side, you want correct logical naming conventions. If a variable holds an age, simply call it age. If it holds a city, call it city. It's that simple. Remember, readable code is functional code, especially when you start working alongside other developers on a team.
All right, now it is your turn to build. This is your very first real coding mission. I want you to pause this explainer the second I finish speaking, open up your Python environment, and write this exact block of code. Set name to your actual name, set age to your age, or maybe just use 22 like we have right here. Set city to Bangalore or literally wherever in the world you're tuning in from right now. Then use the print command to output all three variables. Test it yourself. See the code actually come to life on your own screen.
You've just successfully mastered the absolute foundation of storing data. The big provocative question now is, what are you going to build with it next? The possibilities in programming are literally endless. Once you've completed that practice task, drop down into the comments and type variables done to claim your victory. And hey, please don't forget to like, share, and subscribe to PD Coding Hub so you don't miss our next step deeper into the fascinating world of Python. Keep coding, keep experimenting, and I'll see you in the next explainer.